one of our new initiatives. So currently we are working on we are working on the engineering aspects of developing an air ambulance and the cargo drone for carrying organ transport and for the catering emergency situation in urban population. So the objective of this competition was to promote engineering students and the academia to come up with a conceptual design for the air ambulance as well as for the to cater for the urban population. So based on these concepts, it can be taken forward for commercialization and detailed design stage and development of this into a product. So this is the basic aim of Artpark. So right now, the project team, the our program director, Mr. Hemant Sharma, and our chairman, Omkar sir. So we are all a team of advanced air mobility working on air ambulance and organ transport drone, the development of the product. So this is a brief introduction about Artpark and what we do in terms of advanced air mobility. So
Okay, great.
thank you for the opportunity. Yeah. Thank you.
All right. So I have sent all of you a small message on the chat window. We are also webcasting this meeting live on YouTube. There will be a short delay, maybe about a minute or so, but it can be watched. So many of the teams who have one person on board, they they who are not able to see, they can watch it on YouTube. So with that, I'll go back to the sharing. So thanks to Sharath about the very brief intro to Artpark. So friends, there is a website link on the bottom of this slide. You can click on that to get more information about our partners. So after 5 versions of NACDeC, the 6th version is being partnered by 2 agencies, Artpark and SAE India. Okay, shall we go ahead now? So Prachi, once again, please confirm things are okay. I'm audible,
Yes,
I'm audible and visible. Okay.
Yes, sir.
So what needs to be done in this activity is in 2 stages. The first task is going to be the list shown here. This is what we typically do in NACDeC. I will talk to you today about how to go about doing this particular task briefly. After this, there will be a filtration round. Your reports will be evaluated by a team of experts so that only the very serious and committed teams can continue. And they will be then asked to do task number 2, which is a part of conceptual design, but in much more detail. So we want you to look at the propulsion system in more detail because this is a very specialized design. We want you to look at the structural design. Important thing is cabin design, looking at the communication system. All these things are already mentioned in the problem statement, but we have just tried to put it in 2 tasks here. Okay. Now, it's also important to know what is not expected to be done. Because if you do this, you are going to just waste your energy and time, and you will not get any credit for that in our evaluation. So, for example, estimating the demand for this particular requirement, issues related to operation or maintenance, discussing about maintenance cost, maintenance procedure, etc. Or what are the operational scenarios you will operate. Scenarios you might include, but operational details are not needed. Then what kind of profit or loss will be made by this particular service? What is the indirect operating cost? All these things are not expected to be done by you. Okay. So at this point, I would like to open up for questions related to what you are supposed to do and what you are not supposed to do. So friends, the floor is open. I will stop my share and open the screen for you to ask any questions. So we'll take questions very briefly, only related to the tasks to be done and not to be done, and also general idea about NACDeC. So the floor is open. Please go ahead. Just unmute yourselves and start speaking. You can use the chat window also. It is being monitored by my associate, or you can speak now. Yeah, regarding synopsis, I have a separate slide in the head. Akanksha, please wait. As I mentioned to you, this question round is only for overview of NACDeC and problems, what to do, what not to do in the task 1 and task 2. Okay, probably there are no questions, so I think we'll just then go ahead to save time. Okay, I'm going to talk to you very briefly about aircraft conceptual design, what it is, how to start it, and what is enough for it. Okay. Aircraft design started by looking at simple aircraft, remote control planes, etc. And then we have graduated to much more complicated aircraft like the UAV on the bottom left and the Harrier on the bottom second figure. What is aircraft design essentially? Can somebody tell me? Anybody in the audience can speak out. What exactly is aircraft design? What do you think? And when I say aircraft design, I actually mean mainly conceptual design. But what do you think it is? Anybody? So guys, let us not make it like
an aircraft which comes to meet the
so
the aircraft which meets the mission requirements.
Everybody should just talk about, just tell their name before they speak. Norman, of course, I know you. Yeah. So what did you say, Norman? Once again, loudly.
Aircraft design process leads to the aircraft which fulfill the mission requirements.
That's all. Anything that meets the mission requirement is a good aircraft design. No, that is not
the required aircraft.
No. Just meeting the mission requirements is not enough. Okay. You have to meet the customer specs and airworthiness requirements. And also it should be something which is less expensive and easy to produce in large quantities. That is inherent in aircraft design. Although in this particular problem, we are not asking you how many quantities you have to produce. We are not asking you. But in general, it should also be easy to produce and less expensive. Okay. Now, the customer specifications normally come from three places, either the market or the requirements for operation, or they come from a suggestion or a forecast about the future requirements or some developments in technology, like the use of composites, use of fly-by-wire system, use of control systems, which can now give you autonomous control ability. But there are also some airworthiness requirements which have to be inherently fulfilled. So we will not be listing those requirements. We expect you to yourself decide what requirements from the airworthiness table are going to be required and inherently show that you are meeting those or you are complying with those requirements. Okay. So please note, in the problem statement, we have only given the customer specifications. We have not specified the airworthiness requirements proactively or exactly. You have to figure out then yourself. Aircraft design is done normally in some phases. The first phase is called as the conceptual design, in which the main aim is to ensure that it is feasible and also to identify which requirements are most important that drive the design. We are requested to or expected to carry out what is called as initial sizing and the configuration and layout, and also estimate the component masses, performance, and cost. Conceptual design stops when you freeze the configuration and then start looking at some detailed numbers in the preliminary design. There you are ensuring that the design can actually be realized. You go to the nitty-gritty, you look at the mechanical and structural concepts to be developed, and you develop detailed test and analytical base using wind tunnel testing, detailed CFD analysis, or any other system-based tests. Once you do that, you are now ready for fabrication. So you go for detailed design, where you do the nuts and bolts of design. You design individual components, wing, fuselage, tail, landing gear, instrumentation system, etc., etc. You develop the process to fabricate this aircraft in large numbers. You test all the major items and you finalize the weight and performance estimates. So now I have a question to all of you. What is required for NACDeC-VI problem statement addressing? People can unmute themselves, mention their name, and tell us what do you think is needed. Yes.
Hello, I'm
Yes.
Danisha, and I think required for NACDeC-VI.
Sorry, what is required?
Conceptual.
Conceptual design.
Yes.
Okay. Right. Anybody else would like to differ with the opinion of Tanisha? All of you, I'm sure, have read the problem statement, so you know how much detail we have to go to.
Conceptual design and sizing.
Conceptual design and sizing. So where do you come to the word sizing? It's a part of conceptual design, right? So tell me, conceptual and preliminary and detail, or only conceptual, or tell me among these three how much detail you would like, you're expected to go in this competition. Anybody else can answer?
So Namanuddin this side.
Yeah.
Conceptual design in the task 1 and preliminary in the task 2.
Okay. Anybody else?
Sir, until preliminary design, sir.
Sorry, can you mention your name?
Preliminary.
I'm not able to get your name.
I'm Sagar KP. I think until preliminary design, where we test where we do a CFD analysis on basic various components.
See. CFD analysis is required even in conceptual design. Okay, because how do you otherwise identify the requirements and how do you establish that it is feasible? But in preliminary design, we require detailed CFD analysis. So there is a difference. So just because you do CFD analysis doesn't mean that you will do preliminary design. Anybody else?
Sir, it should be up to preliminary design.
Why is it so?
Sir, because if you're making conceptual design of some aircraft, then we need to know its somewhat details. Okay, we should not know the nuts and bolts up to NACDeC-VI, but yes, we need to know the numbers. We need to know the specifications, like what are the concepts, mechanical and structural concepts on it, which we are applying to it. We need to see in details of it at least.
Okay, I think you don't. You guys need to understand. Be considered as part of the aircraft design, conceptual design. Sorry. Okay, you don't need to do preliminary design in this particular competition. Okay, one simple reason is the name of the competition itself is National Aircraft Conceptual Design Competition. Okay, but all the activities listed in that particular problem statement, okay, you may think that they constitute preliminary design, but no, they are all part of only conceptual design. It is just that we want you to go into more detail. We want you to do a more thorough conceptual design. So we have made the problem statement in two tasks, okay, and these two tasks, the two tasks that we have made, these two tasks are essentially coming under the same idea of conceptual design, but you will not be expected to do preliminary design in this competition. So that is why it is very important for you to realize that you are not going to work on anything beyond conceptual design. Okay, is it clear?
Yes, sir.
Yes, sir.
Okay, great. Let's go ahead. So the first aspect in aircraft conceptual design is initial sizing. Okay, in initial sizing, we have to estimate the takeoff gross weight of the aircraft at the beginning of the mission profile for which you are designing it. That is a task of initial sizing. This is specified by the user. So we have already given you a mission profile in a way. We have told you, we have given you the requirements, and those requirements can be used by you to create the mission profile. And as I mentioned, I will repeat again, there are some requirements you have to consider by the regulatory bodies. Okay. The objectives of this exercise are, first thing is, by doing initial sizing, you get to know which are the requirements that are most important, which are driving the design, and also you can get a first estimate, but just a gross first estimate of the gross weight. Okay, that's all the output of initial sizing. Then the next activity is configuration selection, for which you have to look at the conceptual shape, the functional characteristics, and the position of various components of the aircraft, whether to have a wing or no wing, whether to have tailplane or no tailplane, what kind of tailplane, what kind of wing, are you going to put rotor, are you going to put propeller, are you going to put wing, all that decisions. And these are some of the reasons or some of the aspects which derive the configuration selection. Okay. Right? Mainly it is the functional requirements and safety and reliability. But many a times, depending on the type of propulsion system you are forced to use, depending on the technology that is available, you have to go. And sometimes you also go by history, style, and passenger appeal, although it may not be that much applicable in this case, but sometimes in the broad sense, it does matter. You look at what people have done in the past and try to draw some inspiration from them. Remember that as a team, you cannot say that we have decided one configuration right in the beginning and we are going to do it. You should definitely have few configurations in your mind which will be investigated by team members either in a group fashion or individually. And finally, you have to give a reasoning that we have abandoned concept A, B, and C, and we have kept concept D, or it could be more. But if you say that we began with this configuration right from the beginning, that means you have not done configuration evaluation at all, and that will go against you. So we want you to look at few configurations and then choose one. According to Daniel Raymer, the big 6 parameters which normally affect the aircraft design are listed here. 4 of them, the first 4 are related only to the wing, thickness ratio, taper ratio, sweep, and aspect ratio. But in your case, you may not actually have wing. This is for conventional aircraft. And then the 2 of them are related to the aircraft, which is the wing loading and the thrust or power loading. This will be useful for you also. So the importance of the 2 parameters, wing loading and thrust loading, are that they appear in many performance equations. For example, many of these may not be relevant to you, but if they are relevant, then W by S and T by W are going to be used for both. Then there are some requirements which will be driven only by wing loading, and there are some requirements which are driven by both of them. Okay, so therefore, what you have to do is you have to do something called as constraint analysis, in which you try to get the most suitable values of the thrust to weight ratio, that is sea level thrust upon takeoff gross weight, and takeoff gross weight and divide by the wing reference area. You have to do this, and each of these lines represents one particular requirement. So you pick up a solution space. Now, some textbooks, for example, by Mohammad Sadare, they have the same diagram in the reverse form, because they use WTO by T or WTO by P as the power loading. Doesn't matter. You should be clear on what method to use. Okay. Any questions you have regarding the aircraft design process before we go ahead quickly? We'll go ahead then. Now we come to air ambulance vehicles, the one which you are going to look at for the next several months. If you look at the literature available online, you will find that there are many companies which have tried to address this problem of air ambulance. So if you have done a survey of literature already, can you identify which are these aircraft? Anybody? Can you name them?
So the bottom left is EHang.
Okay. Then any other? Anybody else?
Sir, I'm Vardhman, and the top left is conceptual design from
top left is conceptual. So only one person speak, please. Yeah. Top left is what? Sorry.
Sir, conceptual design from Caltech, I guess.
From Caltech. Correct. From Caltech. Correct. Then next. What about bottom right, the blue color aircraft with 8 rotors?
So it is sure flight.
Correct. It is sure flight. And then we have only one remaining, the one which is called a DP14. It's a twin configuration. There are two rotors. Which is that one? Nobody knows? So guys, this shows how serious and committed you are. You have already given the problem statement. By this time, I expected some students to at least go and search aircraft available. Okay. Basically, this is an aircraft which is used in the health sector. Okay. And our aim is to transport an ill or injured patient from one place to the other. The patient could be under the civilian environment or in the defense requirement. It doesn't matter. Okay. So what are the benefits? The benefits are that the faster you reach a person, the better is the chance of survival. 10 minutes, 15 minutes is considered as the golden period after an accident or incident. Then on the go, you can give some optimal care. So there will be one paramedic on board who will try to look at the important parameters of the person, give some immediate first aid, etc. We don't want people to travel by conventional modes of ambulance on the ground because you can get stuck in traffic, as you all know. So we want to give you a quick commute within the city or in a remote area. It will give a fast and wide coverage. Now, we'll give you an example of a helicopter which has been very popularly used for air ambulance. Remember, this competition is not limited to only helicopter. We are not saying that you should design a helicopter, but we'll try to show you a small video. Okay. Again, I want a confirmation from Prachi or somebody that the video was visible and it is audible.
You can see we have a very spacious.
Yes, sir. It's not visible, but I can
as well as leading
hear
edge.
it.
It's not visible?
No, sir.
Okay. So then I think if it is not visible, I'll have to share it directly from the source now. Just give me 1 minute. Prachi, can you see it?
Yes, sir. It's still, are you playing it?
Seeing are critically unwell.
Yes, sir, it's visible.
And as you can see, we have a very spacious cabin, which is a custom installation by Aerolite, as well as leading edge, future-proof medical equipment. I just can't emphasize enough how much we appreciate the support of our allies in allowing us to do this and care for these critical patients in the back. In fact, I just finished transporting a patient on this very stretcher, and they had a good outcome because of the ability for me to get to that patient and truly provide the care that they required. So let's head to the tail of the aircraft, and I think John wants to talk about a few things there.
One of the new modern features of the H145 is what's called the fenestron. Instead of a conventional tail rotor, there's actually a tail rotor inside this shrouded environment here, which increases safety when we're operating around the back of the aircraft. But the aircraft's still incorporated with the same clamshell style doors.
As you can see when I open them up, they're huge. They allow us excellent access to the back of the aircraft for loading and unloading the patient, as well as our equipment that's secured over on the side. I can show you how the stretcher works here. It's a single person, no lift stretcher. And what this does is it allows us to safely transition the patient out of the helicopter and into the receiving hospital. They might be hooked up to a ventilator, monitoring equipment, blood tubing, multiple infusions, and that's all secure.
Okay. So this is one example, just one example of a dedicated vehicle. Okay, but this is a helicopter. Now, what is the problem in using a helicopter for this particular mission? Just a helicopter? Why not design just a helicopter?
It has a very large size and a great downwash, so difficulty in landing and difficulty in using in every locations where it is needed.
No, but helicopters are much more popular than any other aircraft because their selling point is they can land on helipads, they can land on grounds and fields.
It can the thrust vector of the helicopter is not forward. In cruise conditions, we will need to have a better aerodynamic efficiency. So the power consumption for a helicopter will be much more than the aircraft.
Right. The speed at which you are supposed to fly is quite high. Helicopters do fly at that speed, but they are very, very expensive. Correct? Right? They are very expensive. And
Yes,
also a helicopter is very difficult to maintain because you have the rotor that does everything. It does the forward motion, it gives the lift also. So it becomes a very complicated mechanism. You have a swash plate type of mechanism, etc. So helicopters suffer from very high operating cost, high vibration levels. They also have much more complicated powertrain because you have to connect the main rotor to the tail rotor in the unison, etc. So these are some of the reasons why helicopters can be used. Okay, as you can see this beautiful video, but we are not recommending. In fact, you should do a study and tell us about the benefits of using a helicopter or a non-helicopter configuration. It's up to you. Okay. If you propose a helicopter, we are not going to reject it outright, but I'm sure there are better designs than helicopter which are available. So the basic, okay, by the way, this is the link where you can get this video there at this particular website, stars.ca/H145 tour. Okay, these are the basic requirements, vertical takeoff and landing. Yes, please.
Normal on this side. I just want to clarify one thing. Is there helicopter limited by the battery's power? Because batteries cannot give enough power to operate helicopter for this mission.
True, very true, very true.
As we would like to go electric or hybrid.
Correct, exactly correct. So when you study the design requirements, you will find that a classical helicopter may not be suitable. A hybrid system or an unconventional helicopter can be considered. Okay, so we need vertical takeoff and landing. We need to accommodate one patient and one paramedic. The patient is injured or ill, so the patient cannot do anything except lie on that stretcher. And we need some support. There is a big list of equipment that have to be carried. Okay, the whole vehicle should be within 10 meter by 10 meter size. That is the desired value, but the maximum, absolute maximum is 12 by 12. So more than 12 by 12 will disqualify your design. We will throw it in the dustbin. 10 by 10 is the target. The smaller you have, the better it is going to be. Okay, we should operate it in India. So you have to look at ISA plus 15 degrees centigrade conditions for operation. Don't work under ISA conditions. It should be fully autonomous with no onboard flight crew. This is how it is different from a conventional helicopter mainly. Now, regarding autonomous mode calculations, etc., we are expecting it only in the second stage, some information there, not necessarily in the first stage. Much information. These are the mission requirements which all of you are aware. Okay. We are assuming that the total weight of the passenger, the patient and the paramedic is 170 kg. We want it to travel 100 kilometers at 120 kilometers per hour cruise speed. The passenger cabin volume, we want it to be at least 9 cubic meters. Minimum requirement, length, breadth, height is given. You can have it more than this. That is better, but not less than this. And there is a list of equipment, as I mentioned, which is available in the problem statement. Okay. Now, yes, please. Somebody wants to ask something.
Yes, sir. Krishnakant here.
Speak loudly, please. I can't hear you.
I had a question about range. It's mentioned 100 kilometers. So 100 kilometers is till the patient or the whole mission, like from to the patient and back?
What do you think?
It should be till the patient.
Agreed. Till the patient. From the hospital to the patient. We want to cover a radius of 100 kilometers. Any passenger in 100 kilometers range from the hospital should be picked up. Good question.
Thank you, sir.
Any other query regarding this problem state mission requirements?
So sir, it's a 50 kilometers one way, na?
No.
It should go from hospital to patient, then patient to hospital.
No, it is 100 kilometers one way. Just now I clarified that we want to pick up any patient within 100 kilometer radius.
No, so it is not at the location where the patient is. So we have to operate our vehicle from any of the hospital. Then we go to the patient. Then we count the distance as 100 kilometers from patient to hospital. Is that the case?
Yes.
But what about that distance which we cover from hospital to patient?
That is 100 kilometers max. If your patient is at 10 kilometers, you have spare capacity. You should be able to pick up anybody from a hospital which is 100 kilometers away and bring that person back to 100 kilometers. So assume the radius of action is 100 kilometers.
No, if we go to the patient, so there we are like if it's electric, so are we allowing charging at that station, like at the patient place?
No, the patient will be in
It
the
should be
middle
charged or it should be fueled at the hospital.
At the hospital, Norman, because we don't know where you will go to pick up the patient, whether there will be a charging station there. So it should be self-sufficient, right? The aircraft has to be self-sufficient.
Yes.
It should take off from the hospital, go to a distance of at least 100 kilometers, pick up the person and come back. Okay.
Sir, sorry
excuse
to
me, sir.
interrupt. Krishnakant again, this side. About cruise speed also, can you please clarify? Like, is it max 120 kmph max, or I mean, it should minimum go by 120 km?
There is a meaning of the word cruise speed in aerospace engineering. You don't have to ask me this question. Cruise speed, maximum speed, stalling speed, they all mean something. So this is not the maximum speed. This is not the stalling speed. This is the cruise speed, design cruise speed.
Thank you, sir.
So continue with that. So is this like fixed? You are defining 120, so we have to take it 120. We cannot exceed or beyond in cruise.
When you have a cruise speed of 120 kilometers per hour, it doesn't mean that is a maximum speed. It means
so we can go above it, right?
Yes, but you are not expected. When you go above it, you are going to use a bigger power plant. You should have a reason for having a speed higher than what is required.
Yeah, okay, sir, got it.
Any other question?
Hello, sir. Akanksha on this side.
Yes, Akanksha.
The cabin dimensions and the cabin volume which are given, so that are minimum. We can exceed that.
Yes, please. You can exceed this. Below this is disqualified. Above this is welcome.
Okay, thank you.
But there should be a reason. For example, when you do the layout of the instruments in the cabin, you might say that, oh, to put all the instruments, put the stretcher, to put this, to put that, we need 9.3 meter cube. Fine. Also remember one thing, requirements like this are generally given by the user. May not be necessarily very deeply researched. We pick up the requirements from the existing aircraft. So you have to come back and say, look, your mission requirement of 9 cubic meters is too much. I can fit everything very beautifully in 3 cubic meters. If you can do that, you have to give a justification. But we are saying that generally we feel it should be 9. So if you make more than 9, we will not complain. If you make less than 9, we will look for solid justification. This is what we think is the minimum required. Similarly, if you can fly at 150 kilometers per hour, we will not complain because 150 is more than 120. But if you say we will be flying at 105 kilometers per hour, but in some emergency we can make it 150, 120, not acceptable. In normal condition with proper operation, we want you to be able to cruise at 120 kilometers per hour. You cannot say that with battery only I can do 90 kilometers per hour, but with battery and hybrid I can do 120 and I will normally fly with only battery, only emergency 120. No, you should be able to fly with 120 kilometers per hour in normal condition, and maybe you should give a margin for slightly more velocity also. Okay, similarly, you can design the aircraft for more than 170 kg, but if you say, I am assuming a very slim patient and at 150 kg, that is wrong. Okay, you get it? Okay, let's go ahead now. So this is a typical mission profile that you can consider, because you will have to clear some height. You will be operating in some environment, so you have to clear some height. Then you have to go into a climb and then cruise, because cruising altitude can be a little bit higher. That gives you better performance and clear from all the obstacles. And then you can again come back and land, and again from the site you do it and come back to the place where you have to bring the patient back. Okay. Now, innovation is always welcome, because it can help you in improving your design and meeting some requirements. So we are not giving any special, because we cannot suggest innovate like this. We can just say, but innovation for innovation's sake with no benefit, with more problems than benefit, is disregarded. So for example, one of the designs showed that you can use tubercles on the leading edge of the horizontal stabilizer for having better performance of the horizontal stabilizer. Similarly, you can have hybrid laminar flow control for the stabilizers, vertical stabilizers, but you have to justify by saying that by giving this, I have so much extra weight, and that weight is worthwhile because it reduces the fuel consumption by so much. Okay. So now to do this exercise, you have a lot of resources at your disposal, apart from the standard aircraft conceptual design textbooks like Raymer or Rascom or Nicolai or by Professor John Fielding, etc. You also have online courses available free of cost. There is one course by Professor A.K. Ghosh of IIT Kanpur on aircraft design on NPTEL. There is a dedicated 2-level courses by Dr. Subramaniam Sadarla of IIT Kanpur on fixed wing unmanned aerial vehicles. Okay. Then there is a course which I teach, but my course is mainly on transport aircraft and military aircraft. So you cannot probably apply knowledge directly from there, but you will be able to get at least the design philosophy and the standard procedure. Okay. So you can get recorded lecture of these courses. These courses are not going to run now. They have already finished. Aircraft design course was recently concluded. We got the examination on 30th, I think, of this month. They have already finished the results also. Okay. So, but the videos are still available on the YouTube website. Then we would recommend or suggest some softwares that you can use. You could use Xfile or XFLR5 for basic aerodynamic analysis. Many people use MATLAB or Excel for sizing and performance calculations. CATIA, SolidWorks, OpenVSP, Fusion are good for CAD model creation, but I strongly recommend OpenVSP. Then there are softwares for CFD which are available. OpenFOAM is the most recommended because it is free, but ANSYS, SimScale, CFD++ are other popular packages. And it will be nice if you can document your report in LaTeX software, which is an open source data DTP software, but you may also use MS Word. The important thing is that whatever you use should be licensed to your institution or to you. We are not liable for any damages if you use a pirated version. And if we come to know that you use pirated version, we might take a decision to disqualify your team. Because when you have registered for NACDeC, your institute head has given an undertaking that open source or licensed software will be provided to the students. Access to licensed software will be given to the students. Okay, so please stay away from pirated software. We are not recommending any of these. We are just saying that preferably use open source. For example, there is an open source version of MATLAB called as Scilab, which is available under the FOSSEE program, free and open software program. LaTeX is free, OpenFOAM is free, OpenVSP is free, and I don't know about Xfile and XFLR5. They are also free. So use them. Any questions anybody has? Later on, don't come to me and say,
can we use?
Yeah,
can we use a student version of this software?
You can, if it is allowed for you to use, because you are, if you are a student, you can definitely use student version, but be careful that you don't break any licensing requirements. So you can consult that company and take a call. Generally speaking, student version of softwares can be used for doing R&D work like what you are doing, because you are not doing it for any commercial work. Yes, there is going to be a price, but that doesn't mean. Okay, I need to wind up very quickly because I have to do things. Last thing that everybody wants to know is what should be there in the synopsis report. Okay, so the synopsis report, we have given you that it should be maximum 20 pages, and this is what it should contain. Now, I will take some quick questions regarding the synopsis report. So please, do you have any quick questions regarding synopsis? Please tell me. Ask me so that we can wind up our session.
Sir, could you elaborate timeline of activities?
Just a chart which mentions that during this time we have our exam, so we'll not be doing anything. During that time we are busy with something else. This is how we will do the work. So you have the NACDeC deadlines in front of you. How will you meet those deadlines? What will be your sequence of activities? Some overlap, some lean periods, etc. you should mention. So that we know that you are mentally aware that you have to spend so much time in December, so much time in January, etc. You should be able to meet the requirements within the NACDeC deadlines.
Sir, can we use the number of pages, like for the survey of existing aircraft is given as 5 and configuration selection is given as 5. So can we use survey of existing as 7 and configuration selection as 3, and total number will be 20. Will it be allowed?
Naman, I don't think that's a good idea, because then people will spend less time in doing configuration selection and trade-off study. So I don't think we should give more page for survey of literature and less for configuration selection. This is the maximum number of pages. You can use less than that.
Okay, sir.
Hello, sir.
Yeah.
I wanted to ask if we could use a single A3 Excel sheet for perhaps the timeline of activities, because it would be convenient to represent it in that format, or should we stick to the A4 size?
No, please stick to the A4 size, because we don't want so many details. We don't want it to be, we just want you to give us an overview. So it should be able to fit in a normal A4 size. It's just one page, no? So ultimately you have to copy and paste that page in the, you can just turn the direction and make it landscape if you want.
Sagar here.
Yeah.
Sir, I have a doubt regarding the VTOL performance, sir. Could you refer us any book regarding the performance part of the VTOL?
No, I will not like to do that.
Okay,
first of all, I don't have offhand any direct information on this, but I think you should search yourself and you should use the WhatsApp group for such questions. Maybe some other people can share their information. Okay.
Sure,
so
sir.
right now I don't have an immediate answer. I know that there are books on helicopter like Gesso and Nair, etc., which are very good, but I would not like to immediately. So maybe I will try and get back to you, but right now I don't have any offhand. I cannot tell you.
Okay, thank you.
Look at research papers. Okay, let's go ahead because we need to wind up very soon. So the timeline you know already, 30th November, the deadline for submitting the synopsis report. Okay, then by the end of this year, we will use a month's time because many of us are not available. So we need a month or so. But all teams should continue working, assuming that they are selected. Okay. Then 1 more month you will get because you have only 1 more month. So on 30th November, you submit the synopsis and please continue working for the task 1 because you have only 2 months for that. Assume that you will be selected. Remember one thing, very few teams are going to be rejected in synopsis report because only those teams who just don't do anything or who have a very poor understanding of the problem, only they will be weeded away. Most teams, believe me, most of the teams will continue. Okay. Then you have 1 more month to do the task 2 report submission. Okay. So Yeah, that task 2 is not submission, but it's evaluation. So we need time. So by the end of 30th June, we will give you the evaluation. You can work on the problem. Okay. And then we will so kindly look at the NACDeC web page for more details. Okay. These are the certificates that we gave we gave in the NACDeC competition earlier, in one of the earlier versions, just to tell you that there will be a certificate of first, second, third prize for the teams which come first, second, third out of the 5 teams. There will be a participation certificate for all teams which are shortlisted for task 2, and there will be a certificate of appreciation for all the mentors. Okay. Now these are the 2 people, Pranav, who is sitting on my right hand side right now, and Prachi, who is living in Thane. They are the ones who will do most of the coordination work. You all know them. You know them because they have already been in touch with you. They have sent you the problem statement, etc. And then we have a couple of volunteers, Yukesh and Ajit Kumar Shetri, who are going to help us. They have worked on this problem last year, and therefore they are interested to help us out. So we are very thankful to both the volunteers for helping us with the activities of popularizing this competition and reaching out to you. Okay. They are not taking part in the competition, although they are students. Right. Last slide, last chance for any queries, because then I have to proceed. So open to any queries before we wind up today.
So this is Pavitra here. In the synopsis report, is it necessary to add rough 3D CAD models with the of the configuration selected?
Listen. In the pre-synopsis, you cannot select the configuration because you have not done the design. The design will be done by you only in the first stage and second stage, first task and second task. In pre-synopsis, you will just tell us these are the configurations which we think are promising. But you don't have to you have to understand one thing. The name synopsis means summary. And pre-synopsis is not the end. Okay, so synopsis is just to tell us that you are serious and you know what you are getting into.
Sure, so thank you.
So Krishnakant here,
for the cabin design, could you elaborate more upon it? Like,
what is there to elaborate? You have to design the cabin. You have to tell us the layout of various equipment that have to be put there, and you have to tell us what are the dimensions, where will you put them so that the paramedic can easily reach them. So just now I showed you a video of one kind of a cabin. Similarly, we would like you to make a diagram of the cabin and tell us that this is our layout for the cabin.
Understood.
And that will happen in task 2. We have enough time for it. Right now, I think you should talk more about the pre-synopsis level work, because that is what is in front of you in the next 16 days. Yeah.
Sir, my name is Monica.
Yes, Monica.
Sir, can you please brief about the configuration selection and trade-off study? What should we add in?
Based on a survey of literature, you should be able to tell us which are the configurations which seem very promising, which you will look into, and which are the ones that you will not look into because they don't seem promising based on your survey of literature. That's all. We want to know whether you have at least bothered to check the literature about existing aircraft. Just now I flashed 4 figures. Okay. Many people could tell about 3 of them, but nobody was able to talk about the 4th one.
Yes, sir.
So,
Kartika, please go ahead.
Sir, in synopsis report, you have mentioned the timeline for activities, right? In that, like you have mentioned like lean or no work periods. What does that exactly mean, sir?
Kartika, you must be having some examinations in your college.
Yeah.
During that time, can you work on NACDeC problem?
It must be difficult, sir.
No, it is impossible. I don't want you to work on that. Your college will start complaining, and next year they will not send any team from your college because it will disturb your academic commitments, right?
Yeah, yes.
So tell us which are the periods in which your team is not able to work. That will help us, because that will help us in shifting the deadlines little bit left and right if we need. If we find that most of the teams are occupied with examinations, then that period is a lean period. So we might adjust the timetable. Right now, we have made the timetable based on our own assessment, but we can adjust it slightly.
Oh, okay, sir. Okay, thank you.
So Krishnakant, here there's something called acquisition and operating cost estimation, which is under task expected to be carried out.
Yes.
Can you please elaborate on what comes in the acquisition cost?
I think you have to read
Will
the
it
literature,
include-
my friend. You have to read the literature. Acquisition cost basically means the cost to procure a system.
But will it include the softwares we are using? Like this is specific.
No,
for
no,
this
no.
project, or
This is
will-
not about. This is not about software you are using. This cost is if you have to buy this aircraft
the-
from the. To make this aircraft, what is the cost incurred by the manufacturer? Add to that some profit. So please wait a minute. Before you ask this question, do some homework. As I mentioned to you, I have a detailed lecture on this along with a tutorial for military and transport aircraft on how to estimate the acquisition cost. Kindly read that on YouTube under my course on NPTEL in aircraft design. You will find it, and it is there in all standard textbooks of aircraft design.
All right, thank you, sir.
Sir, Arvind Kapar this side.
Arvind, just 1 minute. 1 minute, Arvind. Alex has a question on the chat. Yes, entire process right up to stage 2, or maybe stage 2. Yes, Arvind. Now please go ahead.
Yes, sir. I want to ask that will you give some instruction about the font that we used that we will use to make the word or something? Instruction
Arvind,
about that.
I have created a document containing complete formatting guidelines, not only the font, but even line spacing, number of this, number of that, how to refer. We will give you detailed instructions on making the report. Prachi, please note this.
Yes, sir.
Have you already sent them? I don't think so.
We are not sent.
So Prachi will share with you a guideline for making the report. The only change is page numbers.
Okay, thank you, sir.
So this is Shripriya.
Yeah.
So I had a doubt on the 3D models. So can we add the models which we have gone through the literature survey, and can we add the 3D models which we have understood from the literature survey in the synopsis report?
Problem. If you have already made 3D models of existing configurations, you can put them. That shows that you have already begun working.
Yes, thank you, sir. Thank you, sir.
Any other point? So if there are no points, then I think we will shut our webinar. We can stop our webinar. So for our record purposes, would you be able to put your videos on so that we can take picture just for our record? Whoever can put their videos on, do it right away. Thank you so much, sir. I'm very happy to see my colleague from HAL. All right, so we'll start taking some pictures. Print screen. Okay, so I have taken one film picture, right? Fine. Just give me a minute. I'll copy it on a document. Okay. Very few people have put their videos on in the second slide. Just 3 or 4 people. Yeah. So this is the last chance for you because we need to stop this meeting very soon. Okay. And screen number 3 and screen number 4. Okay. So I think with that, I'll stop today's meeting. Thank you so much for attending, and sorry for the glitch in the beginning. We were trying to make it on YouTube, and finally we could succeed. So this is available for future use on YouTube. I've already shared the link with you on the chat window. You can just copy it. Okay. We'll also share it on the WhatsApp group. Thank you, and nice to see faces to the names. Bye for now.